Alright, we've worked a little bit with natural logarithm as far as antiderivative so far, so some of this should look pretty familiar. The antiderivative of 1 over x dx is simply what? ln of x. And we do want to put the absolute value. I haven't been a stickler on that, guys, but so far make sure you do start putting absolute values around it, okay, because we do need x to be a positive number. You can't do natural logarithms of negative numbers because remember natural logarithms are really exponents and you can't get a negative number when you take a positive base raised to a power. Okay? You know, like 5 to the negative 100th is still a positive number. It'd be 1 over 5 to the 100th. Okay, so just do put the absolute value margin on there. Let me change it up just slightly. 1 over 4x minus 1.
ln parentheses 4x minus 1? No.
Oh, wait a minute. I forgot that. ln absolute value 4x minus 1.
Divided by 4? No.
Yes, why?
Because the 4 will come out.
Yeah, you did that. Divided by 4, so divided by 4.
To do the derivative of this, you would use a chain rule, right?
Yeah.
The derivative of this would be 1 over 4x minus 1 times 4. Well, we don't want times 4. We don't want a 4. So all you need to do is throw in 1/4 there, or divide it by 4, however you guys want to write it. And then just don't forget your plus c like I did on the last one. Okay? Very similar one right here. X over x squared minus 1.
Divided by 2x? It's like,
Wouldn't it be x ln?
no, oh no. It'd be 1/2 parentheses x squared plus 1.
You mean natural log?
Oh yeah, natural log.
1 over 2x.
But it's to be 1/2
It's natural log
of
x squared plus 1
times 1.
doesn't quite work, right? Because if you did the derivative of natural log x squared plus 1, you'd get 1 over x squared plus 1 times 2x. Do we want 2x? We just want 1x. So multiply it by 1/2. What questions do you have so far? Kind of keep your thinking along the same lines here.
One over
1
1 over x? No.
1 over x plus
Times 1/2. It's just times 1/2.
Yep.
So it's
Isn't
ln.
the numerator half the derivative of the denominator?
yeah.
Like if you do this, natural log of x squared plus 2x. If you did the derivative of this, what would you get?
2x plus 2x.
No, if you did the derivative of the natural log of x squared plus 2x. Sorry, the derivative of all of it. If you did the derivative of this function, what would you get?
It would be 2x plus 2 over
1 over
2x plus 2
x squared plus 2x
times 2x.
times what?
2x plus 2.
2x plus 2.
I was doing that as
Yeah.
just times 1/2.
Because the natural log of something, when you do the derivative of the natural log, it's 1 over that times the derivative of what's inside the parentheses. You guys with me here?
Yeah.
So it'd be 1 over x squared plus 2x times 2x plus 2. Well, I don't want times 2x plus 2, I only want times x plus 1. How can I make 2x plus 2 become 1x plus 1?
Multiply by half.
Multiply by half. Alright? Are you guys seeing this okay? Want me to do it using u substitution? I know somebody that's a no, but anybody? Okay. This will bring back some fun memories. So will this one work nicely with natural logs?
Did you break it up?
Well, we've been trying to just do the natural log of the bottom, right? Okay? Well, that would give us the 1 over x squared plus 1, but then the derivative of what's inside would be 2x, and we're quite a ways from having a 2x, right?
Dude, what if it's the antiderivative of 2x is x squared, so I don't know if we can use that somehow.
I don't know if it would give us the entire expression. So, if we can't use natural logarithms, could we maybe mess with the function itself? To write it differently.
Just break it up.
Wait, assuming factor it?
1 plus.
I wasn't meaning factor, I was just meaning you could like break it into different fractions.
X squared over x squared plus 1.
Oh, you could put that over x squared plus 1, plus that over x squared plus 1, plus that over x squared plus 1.
Yeah, I haven't thought of it word.
Yeah, no, I mean, I like the idea. For some of them it would be okay, but for some of the, one of the terms, it would be fine. The other two terms would be a little more difficult. So, let's actually just divide them. Let's divide them using long division. Yes!
I heard no.
It's my favorite part.
So let's take this, divide it by this. Okay? What you do is you look at the first term here, and you look at the first term here, and ask yourself, this times what gives me this? In this case it'd be 1, right? After we put the 1 right here, okay, we take 1 times
Subtract it.
what's out in front, and we subtract it underneath. Okay, so 1 times this gives me x squared plus 1, but then I need to subtract that amount, so I'm going to subtract what I have. What's my remainder? What's left? X. So that's just my remainder, so do you remember writing things as like mixed numbers?
So it'd be x over x squared plus 1.
So it'd be 1 plus x over x squared plus 1.
I mean, now I can do that.
If you need a little refresher, here it is with numbers. 17 divided by 5, 5 goes into 17 3 times. 5 times 3 is 15. I subtract it, I get 2, so my final answer would be 3 2/5. That's what we exactly just did, except we did it with polynomials instead of numbers. Okay? So now I could rewrite it as 1 plus x over x squared plus 1 dx. And that's actually much easier to do the antiderivative of. The antiderivative of 1 is x. the antiderivative of x over x squared plus 1 would be
1/2 ln absolute value of x equals
1/2 ln absolute value
Plus C.
x squared plus 1 plus c. Okay?
It's been enough time. You just don't. Kind of like this.
We'll do one more.
It's been too long.
The three different ones.
Learned it still.
Alright, so thinking about this one here. I could FOIL the bottom. I could distribute it out, get x squared plus 2x plus 1. But then if I tried the natural log of that, I'd have the 2x part taken care of, but there'd still be a 2 basically that would be in there that we don't want. And it's not being multiplied, it's being added, so you can't just get rid of it by taking it times a half. Let's try and rewrite this function in a simpler method here using u substitution. What do you think you want u to equal?
x plus 1.
Okay, I like it. So let's u equals x plus 1. So what's du then? What's the derivative of this?
X or 1.
1 dx, right? Or just dx. Okay. So then if I wanted to rewrite it, I'd have u to the second on the bottom. Dx is really just du. And I somehow need a 2x on top. Well, this is going to require me to
2u minus 2.
Yeah, I was gonna say.
solve for x.
So x
So u minus 1 would equal x, right? And I have two x's. So essentially I have 2.
u minus u.
Okay, yep, you guys already distributed, which is great. You have 2u minus 2. But I just replace the x with what it's equal to over here. So the antiderivative of, this is what you guys already said, 2u minus 2 all over u squared du. Then we can simplify that. The antiderivative of 2 over u minus 2u to the negative 2 power.
Yeah.
And that would be 2 natural log u minus
Positive 2.
plus 2u to the negative 1,
Yeah.
because the derivative of that would be negative 2 u to the negative 2 plus c. And then you've got to plug in what your u is equal to. So 2 natural log u is x plus 1 plus 2 x plus 1 to the negative 1 power. If you want to put that on the bottom, that's fine. And then plus c. Okay, Jason.
If you would have factored out the bottom and then split it into three different ones, you'd have like 2x over x squared, and that would just equal ln, wouldn't it?
2x over, oh, you can't separate the bottom. I see what you're saying, but you can't do that.
Oh, you want to separate the top?
Yeah, because like,
Yeah, never mind.
You can't do 1/3 plus 1/4. That's a good question. If it was the other way around, you can.
Alright.
Alright, but because of grouping symbols and order of operations, you'd be stuck there.